Okay, good morning. So you can ask me questions from the book, then I try to solve them hopefully here. Yes?
31, 15,
Yeah, so let me... 30?
15.
Which page is that? Okay, so we want to solve this problem. Okay, so they have given you a formula for the volume of this water that you see in this tank. V is the volume, H is the depth of the water, and R is the radius of the tank. Of course, what, putting water in the tank, or is it leaking out? It's leaking out the oil actually. Okay, this is leaking out, so it means that the tank has the constant radius R, but the depth of the oil is actually changing and it is decreasing, yes? Okay, so we want to see okay, can you just give me the numbers here? So what are the numbers? So this is the volume we have. V is pi times h squared over 3 times 3r minus h. R is given for us, yes? What is R? R is 2.5 or 3.5 meters. Okay, and then what we know? We know that the dV dt, the rate at which the volume is changing over time, is 250 liters per minute, yes? By the way, when it is decreasing, it's better to put a negative sign because the volume is decreasing over time. Okay, and then what is wanted from us? How fast the height is actually changing when when the height is 2 meters. So it means that height is also given to us at that moment of time. Of course, h is not something fixed, it is changing by time, but we are interested to calculate the rate at which the height is changing over time when height is exactly 2 meters, okay? So, let us just try to understand the problem. So what is wanted? dH dt is wanted. So first of all, tell me, do you understand that this is what we want, yes? So the rate at which the volume is changing over time is given, and then these also are given, and then we want to calculate this. So you know that the volume, according to this formula, is a function of what? Here R is a constant, not changing, but H is changing, and V depends on H, so we can say V is a function of H. But by passage of time, the value of this quantity is also changing. So it means V depends on H itself depends on time. So it is completely reasonable to say that volume also depends on time. Yes? Okay. And then what you want to write is the chain rule. So whenever you want to calculate this the derivative of this quantity with respect to the final quantity here, T, you can go and use the chain rule. In writing the chain rule, it is easy to write the Leibniz notation. So you take the derivative of V, assuming that H is your variable, but then you have to multiply it by the derivative of H with respect to time. So this is the chain rule. Yes. Okay, so you see that when you read the question, this part is the question mark. This part is already given. In order to be able to answer the question mark, I need to calculate this part myself. Yes? When you want to calculate this part, it means that you want to differentiate V when H is your variable. So this means that in just normal mathematics, we write function of x x squared, yes? If I want to write it properly, so what is that? F of x is equal to pi x squared over 3, and then 3 times r, but r is this number, so let me just write 3r, and then minus x. So if this is the same problem, usually in mathematics, we denote functions by f and variables by x. And then I can ask you find the derivative of f. I don't say with respect to x, but I always mean with respect to x. And now, because this is volume, v is a better choice than f. And because this is height, h is a better choice than x. But I want you to think in that way exactly. Okay, so how do you do that? So you need to calculate the derivative of v as if h is your variable. Okay, can you tell me what to do? It's a very simple problem, by the way. Math 3C students should also take the derivative of that. So how do we do that? Yes? The product rule is possible if you want to attack the problem directly, because this is a function of h multiplied by another function of h. So I have the product of two functions of x, and if I want to differentiate directly, I have to use the product rule, yes? But I myself prefer not to use the product rule because it becomes harder. I prefer to multiply, get rid of the product, and then use exactly like we did in Math 3C. That is easier, but both of them will work. So what I do, I will change the form of the function by multiplying this in. This 3 and that 3 are cancelled. R is left, which will be multiplied here, so it becomes pi r h squared. And then I multiply this here, so this becomes minus pi over 3, and then h squared times h is h cubed. Okay, now you tell me what is the answer to this question, dv dh. So don't get distracted. Might be you're not that familiar or very convenient to write this symbol for yourself, but that is just meaning the derivative. Yes, so what is this one? What's the answer? Yes?
2 pi RH minus...
Yeah, exactly, because pi is a constant, r is a constant, so it seems that I give you this. Everyone, this is, I don't know how can I teach this to you. This is the thing that you need to teach yourself. If I give you this one and I ask you to differentiate it, I am completely sure that immediately you answer that. But when I ask this question, sometimes you have a hard time to understand this. This is something that I want you to teach yourself, because I just told you h is playing the role of x, pi is a constant, r is a constant, so it doesn't matter how you write it down, it's just a constant. It acts like if it is 3 or 5 or whatever. So if you want to differentiate this, you don't care about 3, you just differentiate x squared, becomes 2x. And that's the same story here. So this becomes 2h goes down, instead of putting 2 here, I put 2 there, so it becomes 2 pi rh. Yes? And then what is the next one? Again, pi is a constant, 3 is a constant, so I don't care about this part. The derivative of that one is 3h squared, and that 3 are cancelled, so it becomes minus pi h squared. So that's my derivative. Is that clear? Okay, so what I do, I will go back to this formula. Instead of dv dt, I need to, so let me write this for once. dv dt is equal, dv dh is this quantity, and then multiplied by dv dt. But something that you need to be careful, when you have liter and meter involved, you have to adapt a consistent set of units, okay? Because this is not cubic meter. If it were cubic meter, we didn't have any problems. We can just put the numbers in. But here, R is, so I need to change, so 1 liter, if I want to express it in meter, cubic meter, it is 1 decimeter cube, yes? Cube, yes? So this means that if I want to use the liter, which is 1 decimeter cubed, I choose this unit for the length, for example. I have to change this to decimeter as well, and this one to decimeter as well. So this means that this quantity is not 3.5. It is 3.5 meters, but it becomes 35 decimeters. Yes?
Shouldn't that dV/dt be like dH?
Yeah, that is DHD. Thank you. Thank you. Okay, and then these 2 meters become what? Becomes 20 decimeters. Yes?
Isn't it better to convert everything to meters because the formula is in meters cubed, like for volume?
It is mentioned cubic meter.
But then if you do that, you get like the wrong answer.
No, might be they haven't been careful. Let us just calculate. That's a minor problem. What you have to do is to do it constantly. Okay, that's also not wrong, because what I get is decimeter cubic per minute, because, and then if you want to change it to cubic meter, you can. But I think they have already forgotten to do that themselves, because let us just calculate. Okay, let us see how it goes. So now what should I do? dV dt is minus 250 decimeter cubed divided by minute. Yes, so it is minus 250. Yes, if you want, you can also write the units, but let us leave it. Is equal to 2 times pi times r, which is 35, times h, which is 20, and then minus pi, and then you have h squared, which becomes 400, and then you have dH dt, which is your question mark. Yes? And then I have to calculate this. This is your answer. So let us calculate this. So it is minus 250 is equal to, how much is that? This is 1400 pi. So it is 1000 pi. Am I right?
Yeah.
So this is 1000 pi. And then you have dH dt. So when I want to find this, so I divide everything by 1000 pi. So dH dt is 1000 pi minus 250 divided by 1000 pi. But the units is necessary here. So what are the units? H is in decimeters, time is in minutes, so it becomes decimeters per minute. And then of course you can simplify that a little bit. So dH dt, of course you should also expect to get a negative number because it's also decreasing, so it becomes minus 1 over 4 pi decimeters per minute. Okay, so what is the answer in the book?
0.08.
0508 we need. So the radius is what? 3 centimeters. So this is the volume, yes? 3 cubic centimeter. Okay, and then what happens? The volume is actually getting smaller, yes? Yeah, can you please translate it because it's easier for me to understand it. This means that the volume is actually getting smaller in a way in which the change in the volume per unit time is proportional to the area of that sphere. Yes, so what does it mean? It means that the volume changes over time. How? In a way that is proportional to the area at that time. So let me write the area like this. That is what I understand from this reading, yes? Is that right? So the rate at which the volume is changing is proportional to the area of that sphere. Proportional means it is a constant multiplied by that area. But what that constant is, we don't know. We just know that it is proportional. After 1 month, the volume is 2 cubic centimeters. Okay, so the time is 1 month. Yes? and then the volume becomes this. So this is the initial volume. If you don't mind, let me write the volume when we start looking at this sphere. But after 1 month, the volume after 1 month becomes 2 cubic centimeters, yes? I'm just translating this into mathematical symbols. So when we start, this volume is this one, so it means at initial time 0, we have this. After 1 month, the volume after 1 month is this much, and this is the way it changes over time. Okay, and then part A. Show that, what is this strange word? How do you pronounce it, by the way? Okay, that's not my job, okay? And then so what happens then? So you want to prove this is the case,
Yes.
where K is a constant and R is the radius after T. Okay, so we want to show this. We want to show that the radius changes also with respect to time, which is a constant. Yes? Okay, but I don't know yet this is the constant or not. So keep it, okay. We want to show this is a constant. Because for the time being, I don't really know this constant is that constant. Okay, but let me just claim is constant. This is the question mark for the first one. Yes, so how should I prove it? Yes?
You take the volume
Mhm.
and the derivative, and then it's the same as K multiplied by the area.
So yeah, so why? Because how are you motivated to do that? Because you know that this is the piece of information you have in your hand, which connects V and A, volume and area. But you need to know something about radius. Okay? So this is very motivating what to do. Write the formulas for V and A inside the problem, yes? So if you look at the formula sheet, the volume of the sphere is what? 4/3 pi r cubed. Okay? And then if you look at the formula sheet, A is 4 pi r squared. This is what you have. Okay, this is a little bit tricky. Okay, I want you to tell me, how can I differentiate that? Because if you can answer me, it means that you are on the safe side. We really understand that. Yes?
Differentiate the R because that's R.
So what you are saying is that I write this 4/3 pi r squared. Do you agree with that?
No, because the tree goes with it.
Pardon? Oh, the 3 also goes here, yes. Do you agree with this one? Do you agree that this is the answer for the left-hand side? I can cancel it later, but this is correct or not? Or is it complete or not?
Isn't it multiplied by no?
What is that?
Yes.
Yes or no?
Yes.
Yes or no?
I
Yeah.
think so. I'm confused because it says with respect to
T, exactly. This is what you write if this, I just told you, if you write this, if this is d/dr. If dv/dr as is asked you, this is the end of the story. But this is not asking you dv/dt. This is asking dv/dt. It means that dv/dt is equal to what? Is not equal to dv/dr. Yes, it is equal to dv/dr multiplied by dr over dt. Yes? What you just calculated is this part. This is the only thing that you need to understand in this problem, yes? Do you understand the problem or not? Because I cannot feel it from your faces. Is that clear? So dv/dt. So here again, I have volume as my quantity. We know that the volume of a sphere depends on the radius. In this problem, because of whatever happened to this sphere, this actually is a function of time as well. But if there are different things, dv/dt is not the same quantity as dv/dr. They are related using this formula. They are equal only if this coincidentally becomes 1. If that is not 1, they are not equal. So what you answered here, you considered R as your variable and you just differentiate it normally. When you do that, it means that you are considering R is your variable of differentiation. But this dt shows that my variable of differentiation is not R, is t. So it means that you want to calculate dv dt, it is not equal to dv dr, but it is needed, but it is not the whole story. The whole story is to multiply it by what? dr dt. Yes? Is that clear or not? Yes? Okay, and then I repeat the right hand side. It is k times 4 pi r squared. Then I do some simplifications. For example, this 3 and that 3 are gone. So let me write clearly. 4 pi r squared dr dt is equal to k times 4 pi r squared. And then this 4 pi r squared and this 4 pi r squared are gone. And then, so that was not wrong. Exactly, dr dt is exactly that constant that I put in. So this means that dr dt is a constant. Yes? That was the first part of the problem. So it was not that hard, by the way. Yes? But interpretation. So this is, by reading the problem, you should be able to translate it into this mathematical language. But to be honest, this was a little bit hard because it was unusual to translate. But the rest of it is exactly what we did before. Yes? Okay, so that was the first part of the problem. Now, I think the second part might be hard because what they have asked you to calculate the volume after 4 months. So it means that what is wanted in the problem? V when time is 4 months after starting. So what is your suggestion now?
To somehow find k. Or
Yes, that is good. But how can I find k?
is it proportional? Isn't it like a graph, like a linear function?
Yeah, that's correct. Because you say that I want a function so that when I differentiate it, it becomes a constant. By the way, you have already had Math 3C, so you have some idea about primitive function. But even if you have forgotten totally, you need to ask yourself, how can I write a function so that when I differentiate it with respect to time, it becomes constant k? Okay, what is the most general form? So this is part B. From here, I want to hear from you. What is R of t? Yes? Not x here.
Okay,
No, what is your variable?
KT.
KT. Yes, KT is correct, but it is not complete. Might be I also have a constant, who knows? Yes, is that clear? So from this part, I can conclude that this is R of t. And how many unknowns you see here? Now the plot thickens actually, the problem becomes even harder because I had one unknown, now I have 2 unknowns. But that is not a big problem, why? Because you have 2 pieces of information. And that is why they have anticipated that you need 2 pieces of information to be able to find 2 unknowns. Okay, and the problem is very simple. Okay, now we at 0 is 3, we is 3. So let me write it like this. We at time t is equal to 4 over 3 pi r at that time, whatever it is, to power 3. If I want to calculate the volume when time is t, I have to use the same formula for the volume of the sphere, but I use the r at that moment of time to find the volume of the sphere at that moment of time. This means that v at time 0 is equal to 4 over 3 pi r at 0 to power 3. But v at 0 is given to me to be 3, so this becomes 3, 4 over 3 pi r to 0 to power 3, and then I multiply by 3, divide by 4 pi, it becomes 9 over 4 pi. This becomes this number to power 3, so this means r of 0 is this number. Let me write the third root, it is easier. It is centimeters. Yes? Is that understandable? Yeah.
Why did we put R of t?
No, because this is reasonable, yes. Volume. You need to be flexible, okay? So V is a function of time, is a function of R. But R itself is a function of time. So if I ask you to calculate the volume of this sphere 15 days from the beginning, what do? You need to know the radius after 15 days so that you can put it in the formula for the volume and find the volume of the sphere after 15 days. So it means that the volume after t days is equal to this. When R of t is the radius exactly after t days. Is that understandable? But of course, a day is not the it is counted based on month. Okay? So is that understandable? So if I ask you write this in words, what do you write? You would say that the initial volume of this sphere is this number. Yes. So when we start, look at this problem. The radius is this. Okay, but now I also know that the volume after 1 month is 2 cubic centimeters. So it means that V at 1 is 4 over 3 pi R at 1 to power 3. But V at 1 is given to be 2, it is 4 over 3 pi and then R at 1 to power 3. So I simplify 2 with this 2 and then it becomes what? 6 over 4, which is 3 over 2 pi is R1 to the power of 3. So finally, R after 1 month is the third root of 3 pi over 2 centimeters. Yes?
Will you put this out there?
Pardon?
Would you put this video out?
I'm trying to record it. Yes, I will do that. Yes. Yeah, it is being recorded, yes. So is that clear up to here? But now I can use these pieces of information to find these two unknowns. Yes? Okay, so how should I do that? So let me use those pieces of information. So we realize that R of t is an unknown constant k multiplied by t plus another unknown constant c for the time being. But we also realize that R at 0 is this number. So this means that R at 0 is the third root of 9 over 4 pi. What does it mean? It means that if you go to R, replace t with 0, the answer is supposed to be this value. So I do the same thing. I go to R, replace t with 0, I get c. It's supposed to be this number. Is that understandable or not? So this unknown is actually found now. Yes? And then, now that I have c, I have another piece of information to use. R at time 1, R1, is equal to the third root of which number? 3 pi over 2. So this means that if I go to R, replace t with 1, the answer is supposed to be this number. If I go here, replace t with 1, I get k plus c is equal to that number. Of course, I don't have calculator. In the middle of the way, you can use your calculator, even though I don't like it. I prefer to solve the problem exactly until the very end and then use the calculator. Because if you start doing the calculator in the middle, you start accumulating the errors. Okay? So then c is this number. So in your head, put c here and then move c to the other side to find k. So it becomes even a stranger number, yes? This is your k. So if I ask you, do you know R? You would say yes, because I already know c, I now know k. So what is RT? Is not a complicated function. It's a linear function. The constants look a little bit odd. Yes? So k value is this number. C value is this number. I don't know if you, for me, it's more comfortable to work with exact numbers. If you don't like it, in the middle of the work, you can just put these numbers in your calculator and get a very tangible number for yourself. I don't recommend that. This is it. Yes.
Shouldn't the negative sign be behind the third root of 9?
Yes, thank you very much. Thank you very much, because this one is this one, I move it to the other side, you are right. So this should be plus,
And the other one.
this should be minus. Thank you, and then I will do the same thing here, plus and minus. Thank you very much. Okay, and then what I'm supposed to do? I am supposed to calculate the volume after 4 months. So how should I do that? To calculate the volume after 4 months, I need the radius after 4 months. Yes? But I can calculate radius at any time because I have its functionality, yes? So what I do, I calculate the radius at 4, okay? So this becomes 4 times this number. Yeah, I mean, I hope that you understand this is not a very big problem. The reason it seems horrible for you might be because of this messiness of the numbers. But these are just constants. If you don't like it, I don't think you will lose anything for this particular problem. You can put these calculators in the middle of the way and work with just decimal numbers, yes? Okay, and if you want, I can simplify this a little bit. So I multiply it by 4, 3 pi 2, and then minus 4 plus one of them becomes minus 3. So this is centimeters. So the radius after 4 months is this number. But they ask you about the volume after 4 months. So what I'm supposed to do? It's easy, yes? So what is that? The volume after 4 months is equal to 4 over 3 pi, the radius after 4 months to power 3. So you raise this number to power 3, multiplied by 4 over 3 pi, and that is your answer. Yes?
You should raise that number to the power of 2, right?
Yes.
The value for R.
Yes, but don't get confused. You're not allowed to raise this to power 3 and that one to power 3. Yes, because a minus b to power 3 is not just a to the 3 minus b to the 3.
Yes.
This is not correct. No, I felt that you want to do that mistake. Yes, I just wanted to prevent that. Yes? Anyway, so this is the number. So if you don't mind, let me just try to see if I have done it correctly. Let me just put everything in GeoGebra, but also GeoGebra is not that easy to put this number in. So what are the numbers? So I have to write 4. So let me use the keyboard here, 4. And then I have to multiply it by pi, which is this one, and then divide it by 3. And then multiply it by, clean that one, and then I have to go up. And then multiply it by that whole combination to power 3. So it means that I have to write that, and then I have to write 4 times. Okay, do I have any third root here? Do you know that? These are good things, by the way, you need to learn in GeoGebra. Yes, I have the third root symbol here. So this is the third root. So I put 3 here, and then I go there. What is the number? 3 pi over 2. Okay, and then I go out. And then I have, again, out minus 3 times. I go back here, and then I choose this symbol again. Then I have the third root. Oops. I hate just GeoGebra. This is why I'm... Oh, it's gone back. Learn these things because it is really distracting on exam time. Yes, if you don't know how to manipulate these things. So then I will go here. What is the answer? Okay, third root of 9 over 4 pi. So finally, hopefully, this is going to work. And then I go outside and then raise it to power 3. This doesn't seem good. How is that possible then? Uh, 3 pi, and then this number, did I type it wrong? Oh, this is a very, very strange number. Yes, I made a mistake. You didn't tell me that time. This pi is not on upstairs, yes? So this pi, I made a mistake. This pi is not here. Because this pi goes down. This pi is here. Okay, so every pi that you see here goes down. Yes? Now this should be correct, hopefully. So how can I fix it here? I hope that I can fix it. I can put this pi down there, yes? Pi here. I don't know, can you see the answer?
0.36.
Yeah.
That's that answer. So that was my mistake, sorry. But that's correct. And the units you should also include in the national exam. By the way, in the national exam, there are some points for not writing the units. So if you calculate all these things, don't write that unit at the end. What is the unit? It should be cubic centimeters. So they ask me to deduct some points, you know. So you have to be very careful when you want to write the national exam. Okay, so that is it. Yes? Yeah. So by the way, this is the level of the questions in the national exam, usually. So you have to be prepared. This is why I increased the level of difficulty for the coming exam to have a little bit of challenge, yes? No, I'm just kidding, okay? But I want you to know that you need to know at this level if you want to do national exam. Okay. Any questions? Is that understandable? So if you want to summarize what we did, it was not that hard. I would say that the only thing from my perspective is to read the text and be able to write that. For me, if you see, I was stuck a little bit of understanding the problem. But when I was able to write this, then after that, I would say even though the algebra seems a little bit complicated, I myself made 2 mistakes. Yes, one casual fixed that, one of them myself fixed it later. But then everything is natural. I'm saying that in the national exam, if you don't like to do these things, you can put this in the calculator. Instead of this one, you can have a more friendly number in front. But I prefer to do it everything algebraically, and I really advise you to try to use GeoGebra a lot. So there are some standard features usually doesn't work because Control-C and Control-V should work in Windows, but sometimes it doesn't work here. So you need to learn these things in a way that you should be able to rely on the answer that you get from GeoGebra. Because here, assume that I made those mistakes and I get a number, I don't have the faucet to compare it with that. Yes?
Do we have to use GeoGebra in the exam?
Yeah, I'm trying to manage that. Because for the second booklet, the first 2 booklets are without calculators or digital help. And for the third one, you are allowed to use your calculator or any digital tool. So I won't try to manage to give you access to GeoGebra. Because doing these things in a very small display might be not. But that's up to you. I will give you access. And I try to find a way I'm communicating with them. Because you know that I could put the exam in exam.net, but I'm not allowed to do that because the people who are in exam.net shouldn't see the questions. But that's the problem. So the questions shouldn't be exposed. So I cannot put the questions there, but I can give you still access to GeoGebra. So you have to have your laptop with you, but still do the calculations there, and then you can write on the paper. Yeah, I will manage that. That is my problem. Don't worry about that. I will try to give you access to GeoGebra and any other software that you need, which is allowed actually. Any questions? Okay, any other questions? Yes, please.
3249.
So if you give me the number of the page, that would be also very good.
97.
90?
7. Yes.
97. Where is that? 96. This should be 97. Which page? Which problem?
49.
Which problem?
49.
97. You said. 49. This one?
Yes.
Okay. So let us understand the problem. Tangent to this curve. At this point on the curve makes a triangle with the positive parts of the coordinate axis. Yes, you want to find the area of that triangle. That's the problem. Okay. I don't consider this a hard problem. So for example, in the previous problem, I can consider it a hard problem because I have to think about what to do in the beginning. But this is a very standard problem. Even though I agree, compared to the other parts of this book, this considered to be a level 3 problem because it needs your analysis, yes? So you need to understand what is going on. So you don't need to draw good pictures. You have something in mind. So this is one curve. Even I don't care if this curve is close to the reality there, yes? Of course, yeah. And then you have a point on it. This important information is that this point is 4, and then you draw a tangent line here, and this tangent line will go and cuts the x and y coordinates, and then of course you can see that I get a triangle, and I want to find the area of this triangle. Yes.
It was more the tangent that was hard to imagine how it should be.
You don't need. I don't even know if it is close to reality. By the way, let us just. But I know that. This is not, because if you draw the curve like this, might be you are in trouble, yes? Yeah, because if you just draw, if this is 4, and then you draw that, then of course, this will go and intersect this in the negative part. So somehow, by giving that this will intersect the positive parts, it's giving you some hint. I don't know if this graph that I have drawn is close to reality, and I don't spend my time thinking about it, yes? According to them, this has happened. So I don't care about how this happened. My problem is to find the area of this triangle.
So you just find the k by deriving, and then you have x, and you find y, and then you find m.
Yeah, that's the reason that the way that I think is this. I don't, let me repeat this. When I want to solve a math problem, I don't try to give you a lot of points. I would say that, okay, I don't care what is this. I focus on finding the area of the triangle. So my starting point is what I need. This is the question that I ask myself, what I need to find the area of the triangle. Okay? So what I need to know this. I also need to know this. The second question that I ask myself, what are these question marks? This is a line. So it means that if I know this line, I can find this point and that point. So the next step is that, okay, how can I find this line? Then I ask, okay, what this line is tangent to this curve. Then I ask, how can I find the tangent to the curve? So I actually go from the bottom of the problem to the top. So this is the way that you have to think. Okay, so now you understand that you have to find the equation of this line. This is why I'm saying it is not hard, because that is a very typical problem, finding the tangent to the curve. So what I need to do, this is my function. F of x is x to the power of what? 3 times e to the power of minus x. Okay? And by the way, they put this dot to give you a hint. That's a product rule. I will not put these dots in the exam. So when I write x to the power of 3 e to the power of minus x, you need to understand yourself that's the product rule. Yes? Anyway, so if I want to differentiate this function, the product rule is the derivative of the first one, which is 3x squared, multiplied by the second function plus the first function itself multiplied by the derivative of that function, which is minus e to power minus x. So I write minus x to the power of 3 e to the power of minus x. Okay, and then I want to find what? I want to find the k value. But for the k value, I need not only the derivative, but I also need the x-coordinate of the point of tangency, which you read the problem, it is given to be 4. So I need to calculate f prime of 4. And I put this into the function, so this becomes, let me just put it here, 3 times 4 to power 2 times e to power minus 4 minus 4 to power 3 times e to power minus 4. If you calculate that, 48, 64, so it's minus 16 e to the power of minus 4. Or if you want, you can write it as minus 16 e to the power of positive 4. So that is my k value. Yeah, is that understandable? Okay, now that I have the k value, I need to write the equation of that. So what is that one? So this is y minus y node. In this case, y node is f of 4. So it becomes f of 4 is equal to the k value, which is f prime of 4 times x minus 4. This is the equation.
That's the
for the
hard
k.
part. How do you know that? So what's...
No, this I told you before. In Math 1C or 2C, it depends to which book you have used. You usually write this. Yes? And then you put k in, okay? And then you put the point in after you found k to find m. But the final product, I think, is also in the formula sheet, so you don't need to memorize that. So if I have a line, the k value is given, a point is also given, then I can write y minus y node is equal to k x minus x node. I'm using this formula. And that is not a new formula, that's the same formula in which m is already calculated and plugged in. Okay, I think this is also in the formula sheet, okay?
Can't you not just like take the original function to find y and then you have k and x and then
That's what I'm saying.
Yeah.
If you are comfortable with that method, just do that. So you found k from here, put it here, and then x is already given to be 4. You put 4 here, and then you get y value. You put x and y value. You already have m. You found m. That's correct. But if you do that, that is what you get at the end.
Yeah.
This formula gives you the same thing. You don't need to calculate m indirectly. Yes? It has already been calculated and plugged in. Yes? So that's up to you which one you want to use. And then y minus f of 4. What is f of 4? F of 4, I have to put 4 here, so this becomes 64 over e to power 4. So this becomes 64 e to power 4, and this one is minus 16 e to power 4, and x minus 4. By the way, in this problem might be that this method is easier, that's up to you. Okay, so let me simplify that, because usually we put y here and move everything to the other side, so this becomes minus 16 e to the power of 4x. I move this to the other side, this one and that one, this becomes 128 e to the power of 4, yes? Because this is positive 64 over e4. If I multiply that in, that's also positive 64 e to power e. This is positive because I moved this to the other side. And this quantity becomes 128. So this is finally the equation of the tangent line. And by the way, here you are not allowed to put in the calculator. So you have to use the exact value. Only in physics problems or practical problems you're allowed to put the decimal points. So in this problem you have to work with e in this 4. Okay? Okay, now this is the equation of this line. I need this question mark. This question mark should be very easy for you to answer. What's that question mark? That's the m value. So that's the m value. So this so this is what? 128 over e4. And now I need this one as well. So what should I do here?
Do it to 0.
I need to put y equal to 0 and find x. I put y equal to 0. When I put y equal to 0, it means these quantities are equal. And then you can see that I can multiply by E4, and I can divide by 16, which becomes 8, yes? So this is 8. And now I want to find the area. So the area becomes 1 over 2, the height, which is 128 over E4, multiplied by the base. 1 over 2, this is 4, 4 times this is 512, yes? Divided by e to power 4. Area units. I don't know if this is the answer. Is that one? You can check it yourself. Yes, that one. Yes. Is that clear? So again, if you do not see the problem in this way, I agree it is hard. But you see, when I want to solve this problem, I read the problem once, but I start exactly with the question. The question is to find the area. I ask myself, how can I find the area? The answer to the question is to find this and this. And then I ask, how can I find this too? I realize these are the intersection points of a straight line. So I ask myself, okay, to do this, I need the equation of my line. To find the equation of line, I need the equation of the tangent line, and this is a standard problem. If you have already started learning that, then you can do it immediately. Any other questions? Is it finished the time, or we have time? Yeah, we have time, I think, yes. It should be 12th day. Yeah. Yeah, I think so. Yeah, I can check. Any questions? We have 20 more minutes.
Should we take 15 inblandade uppgifter?
Yes, you can take whatever you want to. 15 in... can you tell me now, what is your opinion about how to solve that problem?
Okay, so I think you should find the derivative of y prime first, so it's -1, and then as well as the other one, and then you put -1 for the other one, right?
So why is that?
And then you can find x, I guess.
Okay.
Yeah, and then...
So you have the clue why we are doing that, because again, you need to have, you should be able to analyze the problem. So for example, you have a curve, I don't care how the curve looks like, really. This is my curve, whatever it is. And then I have a point, and I know that, by the way, this is a wrong, really wrong problem. So, because y minus x is in this direction, yes? Okay, but we don't care. So just we go to a scratch work, we know that I have a curve and I have one equation to it, yes? Usually, I give you this point of tangency, and then I ask you to find the tangent line. They have actually reversed the problem. They have already given you the tangent line, and then they are asking about this point A. Yes? Okay, but you know that the k value is equal to f prime of A. Yes? Okay, calculating f prime of A is easy because f prime of x is what? 3x squared minus 12x plus 8. So when I say f prime of A, it becomes 3a squared minus 12a plus 8. And then I am supposed to calculate q, but I already know in this problem k. K is the k value of the tangent line, which is easy to read, it's -1. And then you solve that one, you find a. So you just move it to the other side. It becomes 9 equals to 0, and everything is divisible by 3, so I divide everything by 3. It might be there is a good point here as well, because this is a second degree equation. Let us see how it goes. If I divide by 3, it becomes 4a plus 3 equals to 0. PQ formula, ABC formula, but might be it's better to factorize if you're quick in that. So I need two numbers with the sum -4 and the product +3. So these are these two numbers, and that is interesting. So you get two values. Okay, so what is your interpretation? That's also tricky, might be. This is a good question, actually. So are both of them are acceptable? So this means that if this is going to be the case, this tangent line touches the curve at 2 points.
Maybe you should put it in the function to see if one of them may be like a fake root or false root.
Okay, so but do you have any ideas? This is important. By the way, that was a good question. I couldn't see this going to happen. might be, if both of them you say is acceptable, it is possible, by the way, isn't it? For example, I know that for the third degree polynomial, might be it is not possible. But for example, in general, you might have something like this, and then you have one line which is touching your curve at 2 points. I know that this situation does not happen for the third degree polynomial, because the third degree polynomial has at most one maximum and one minimum. It cannot have this situation. But in general, it is possible for a line to touch the curve at 2 different points. Now the question is that, because you do not have enough knowledge in your memory about the third degree polynomials, so you might think that both of them are acceptable, or if one of them is acceptable, which one is that? How do you answer this question? First of all, this is not enough, because this is just the x-coordinate of the point of tangency, and the problem is asking for the point of tangency. So the next step is more or less for your natural. You are supposed to put this there into the function to find the y value, yes? So what happens? The y value here becomes what? F of a becomes 1 to power 3 minus 6 plus 8, which is 9, this is 3. So if this is correct, this is the point of tangency. But if a is 3, let me put it there, f of a becomes what? 3 to the power of 3 minus 6 times 3 to the power 2 plus 8 times 3. So 27, 24, 51, and this is 54. So it is what? Minus 3. This becomes minus 3. So this is important. Are both of them acceptable? Or if not, one of them is acceptable, which one is that? Yes?
I think the y value of this should be equal to the y value of the tangent.
Exactly, because don't get confused, because this point of tangency not only lies on the curve, but also lies on the tangent line itself. Every point on the tangent line has these relations between x and y coordinates. So you see, this point of tangency is a point which is not only on the curve, but also on the tangent line. So it means that the coordinates of the tangent point should satisfy not only the function, but also the tangent line. But this does not feel that, yes? Because 1 and 3 is not on this line. Yes or no? Okay? So this means that this is the only one, because it fits there. So this is not acceptable in this problem. This is the answer. But that was a good question, actually. So if this wouldn't happen, I also consider it level 2 problem, but might be also deserve to be a level 3 problem, because you need to add, and you need to write this, by the way, in words when you want to say something like that. Okay, so that was unfortunate. I didn't record this. Yeah, I record my voice with this slide. Anyway, yeah, you can take a photo if you want to. Yeah. Any other questions?
Thank you so much.
No.
We have everything is
Yeah, good. You don't have any questions? Yes? The page and the number. Page 84, so read quickly. So if you want to calculate h prime, I solved that problem when I was teaching. Okay, so h prime, so the function h of x is given to be f of g of x, and then you are supposed to find h prime of 2 using the information given in the picture, yes? This is something that I mentioned when I was teaching. You are not allowed to guess these curves. So even though this curve is a straight line, you are not allowed to guess it. You need to use exactly the information given in the problem. So you cannot say, even though I realized when I solved the problem, this is really y equals to x squared. But if you assume that y is equal to x squared and start solving the problem, I will not give you any points, because that's not the point of this problem. So you have to use the chain rule. And it is not hard for me to design a question that is not the y squared and you cannot guess. But still you can have these kind of questions. Okay, so if you want to solve that one, I need to use the chain rule. So h prime of x, according to the chain rule, which you have the formula with you, you will get, this is f prime of g of x multiplied by g prime of x. So this is the chain rule. But then the question is, what is h prime at 2? So this means that I have to replace every appearance of x with 2. So this becomes h prime of 2 is equal to f prime of g of 2 multiplied by g prime of 2. So in order to answer my question mark, I need to know what is the value of g2. I need to know what is the value of g prime of 2. But then I can go back to the information on the picture. So if I ask you what is g of 2, g is this blue curve. And I want to ask what is g of 2. So this is 1, this is 2. G of 2 is this much, which you can read it. How much is that? It's 4. So g of 2 is 4. Yes? And then g prime, this is this red, this is this yellow line. This is g prime. And then you want to know what is g prime of 2. So again, this is 1, this is 2. I go to up to where they intersect. That's exactly the same point. The same point is also on the yellow line, and then I go here, then it becomes 4 again. So this is also 4. So so far we have f prime of 4 multiplied by 4. Then it means that I now need f prime of 4. To answer f prime of 4, I need the graph of f prime, which is this red line. So again, I go to number 4, 1, 2, 3, and 4, and then I go up to intersect the red curve, and then I go in this way. How much is that? 1, 2, 3, 4, and 5. So then it becomes 5 times 4, it's 20. Yes? First of all, is the answer correct?
Yes.
Okay, so that's the way that you have to solve these kinds of problems. Any questions?
Ibland ger det för att du vet redan vad ett av g av x är. Sen
By the way, for example, now I see I will not give you this question because this is relying on your knowledge from Math 3C. I haven't taught that optimization yet. This is an optimization problem, but I will not give you this in the exam because I am supposed to teach you optimization. So for example, this you don't need to study. Or any kind of optimization problems, if it appears, just don't study them because that would be, I will teach you later. Yes?
Also, 42.
Okay, 42 is just, if you need to put the formula sheet in front of you, yes? Because this is just a very simple differentiation and this has a formula for it. By the way, I don't know which version of the formula is in the formula sheet, but f of x is 3 to the power of 2x and then minus 2x plus 1. You want to find f prime of 2, yes? Because you want to find the slope of the tangent line when x is equal to 2. So in principle, they are indirectly asking you to calculate f prime of 2. But if you go to the formula sheet in the table of derivatives, you have a formula for these kinds of functions. But not with 3. It is written, if I remember correctly, a to power x. And if you want to differentiate it, there is a formula in the formula sheet tells you that the function repeats itself and then you multiply it by ln of a. That is the formula in the formula sheet. But what is important is to understand that 2x to power 3 and 3 to 2 power x, they are different rules. They are not the same. So if you understand that one, you need to solve that one. But here, I do not have any number. So what I do, I would write 3 to power 2 to power x. then this becomes 9 to power x. Yes, and then I can use exactly that formula. So f prime of x, according to this formula, the derivative of this one becomes 9 to power x itself, but I have to multiply by ln of 9. And everyone knows that the derivative of this is minus 2, the derivative of that one is 0. So this is my derivative. But here the question mark is f prime of 2, so f prime of 2 becomes 9 to power 2, which is 81, ln of 9 minus 2. I don't know what they have written as the faucet. If this is different, you can tell me to convince you that this answer is the same. Yes.
Can you do 41 as well?
Okay, this one. So this is this problem. So we want to differentiate this function. That's a good problem. They have considered level 2 problem. So let us solve that one. F of x, what is your opinion about how to solve it? 1 over square root of x plus x to the power of 4. So how should I solve that one? Yes?
I was thinking to put it like S of f of g of x. So having like 3 different
Yes.
applications on it.
Yeah.
The first one, the g of x, the inner u, square root of x plus x, and then the f of x 1 over x, and then the s of x.
So that's correct. That's correct. But instead of doing it like that, if you don't mind, that's exactly the same thing. Let me bring it up and then write it as square root of x to the power of minus 4 instead of that. Yes? But what you said is completely correct. Okay, but then you need to give the role of u to this guy, and then you ask yourself, what is the derivative of this one? Okay, you know already what happens, minus 4 goes down, and then you have u to the power 1 less, which is minus 5, but that's not the whole story. By the chain rule, you know that you have to multiply by u prime. So I do the same thing here. So minus 4 goes down, and then I have square root of x plus x to the power of minus 5, but I have to multiply by the square root of x plus x prime. This is why I always really want you to memorize square root of x, because otherwise you have to start everything from scratch here. Okay, and then I would write this to the power of minus 5. The derivative of this one, I already told you, memorize that. If you don't memorize it, that's okay, but you have to derive it on the exam session. That's the answer. If you want to make simplified version of that, I don't know how they have written it in the faucet, you can actually make it more beautiful, yes? So for example, you can take the common denominator here, and then you have 2 square root of x plus 1. If you want, you can take this back into the denominator and make it with positive power, and then do some simplifications. For example, this minus 4 and this can be simplified, so I have minus 2 times 2 square root of x plus 1 divided by square root of x times square root of x plus x to the power of 5. Yes. But for me, in this exam, because if I ask you to simplify it, you have to continue. If I don't, you can stop just there. Yes? Okay, any other questions? No? Okay, good luck, thank you.